To understand what a probabilistic model is, let's have a look at the example. An important consideration in taking a drug is how it may affect one's perception or general awareness. Suppose you want to model the length of time it takes to respond to stimulus, a measure of awareness, as a function of the percentage of a certain drug in the bloodstream. The first question to be answered is this: do you think that an exact relationship exists between these two variables? So, the length of time it takes to respond and the amount of drug in the bloodstream. So that is, do you think that it is possible to state the exact length of time it takes an individual subject to respond if the amount of the drug in the bloodstream is known? And there are two ways to model the above experiment, using a deterministic model and using a probabilistic model. So let's start with the deterministic model, which hypothesizes an exact relationship between two variables. So for example, y is equal to 1.5 multiplied by x. So y, which is the reaction time to the drug in seconds, will be exactly 1 and 1.5 times x, the amount of drug in the blood. So if you look at this model, you will see that there is no allowance for error in the prediction. So the relationship is exact, which means that we can precisely estimate the reaction time of a person. But I think you will agree with me that this is very much unrealistic, because our reaction to a certain drug might also depend on our age, on the time of the day when this drug is taken, and on some other factors, which, if we don't include into the model, should be the error in our prediction. Therefore, the better model for constructing this type of relationships is using a probabilistic model. This is the model that includes both a deterministic component and a random error component. So if you compare this model with the deterministic model, you see that the only difference is that now we have the random error, and all those unincluded variables, so all those unincluded factors like age, time of the day, etc., are counted by this random error. So if you look at the graphs of deterministic and probabilistic model, you will see that in case of the deterministic model, the value of x and y lie on a straight line. However, if you look at the probabilistic model, you will see that the straight line that is constructed does not always include the value of x and y. And when those values don't lie on this line, the difference between the line and the, as we call it, the observation or the value of x and y, is the random error, whereas the straight line is a deterministic component. Here is the general form of a probabilistic model. So y will always be equal to the sum of the deterministic components, so the mathematical or the statistical relationship that describes how y reacts when x variable changes, and the second component is the random error, so something that we haven't managed to include into our equation. And the mean value of this random error, we will assume, is always equal to 0, which means that when we calculate the mean value of y, it will be always equal to the deterministic component. And here is a first order or straight line probabilistic model. So y, which we will from now on call the dependent variable or response variable, is a function of beta 0 plus beta 1x, where x from now on will be always called the independent variable or predictor variable, plus epsilon, which is the random error component. So since epsilon is the random error component, that would mean that beta 0 plus beta 1x is nothing else but just the deterministic component. As for beta 0 and beta 1, beta 0 is the y-intercept of the line, so this is the point at which the line intersects to cut through the y-axis. So since the mean value of the epsilon is always 0, so when x is equal to 0, y will be equal to beta 0. This will be the point of intersection with the y-axis. I will show you the graph in a second. Actually, I can show it now to you. So here is the point of intersection, which is, so the value here is equal to beta 0. And beta 1, this is the slope of the line. That is the change in the deterministic component of y for every 1 unit increase in x. So in other words, it shows by how much y will increase if x increases by 1 unit. And this is nothing else but just the derivative of y with respect to x, which we already know, or should know, that this is the slope of any linear function. So beta 1 is the slope. And please remember that the positive slope implies that there is a positive relationship between y and x. So that means that when x increases, y will increase as well. And a negative slope implies that there is a negative relationship between y and x. So when x increases, y will decrease.